Welcome back to another AP Pre-Calc video. I'm Mr. Hibble. Today we're looking at our 3.16. This is the first of two videos, so make sure to come back for the next one as well. Now we're starting to look at rates of change in polar functions. So, few things to know. Given a polar function, looking up at the top, given a polar function f of theta, we know r represents the signed radius of the function. We use this phrase signed radius because r can be a positive or a negative value. As we trace the graph of a polar function, we are interested in whether the graph of r equals f of theta is getting closer to the origin or further from the origin over a given interval. Remember, that signed radius simply is talking about the distance from the origin. Well, another way to consider that is if you were to graph the function in the xy coordinate plane. If you graph it in the xy coordinate plane, now you're thinking about the signed radius r as the distance from the x-axis. Okay, let's go ahead and look at this. What we want to be able to analyze is the distance from the origin and whether that is increasing or decreasing. Well, what that would mean is there's a few things you can look at. If the function is positive, meaning above the x-axis, and increasing, meaning the function is going up, that would mean your function has a distance that is increasing. If it is negative and decreasing, below the x-axis and going down, the distance from the origin is also increasing. Well, that makes sense because if it's positive, again, that's above the x-axis, increasing is going up. Well, if I look at this section of our graph here, we see that is true. It's above the x-axis, it's going up. The distance from the x-axis then is increasing. That would represent the distance from the pole. Same idea with the decreasing side of things then. If we look at a function and it's positive but decreasing, that means the distance between the origin is decreasing. Notice here, it is above the x-axis, but now it is going down. You are getting closer to the x-axis there. We know that the distance is increasing if it's negative and decreasing. We know the distance is decreasing if it's negative and increasing. Okay, just different ways to analyze your function there. Okay, whenever we do this stuff, it is nice to note that you can analyze this stuff not on a polar graph. You can analyze it instead on the xy coordinate plane. Which makes this stuff a lot easier to visualize because we're used to that coordinate plane. Let's go ahead. Let's look at an example. The AP exam tip is exactly what I stated before. It is often helpful to sketch the graph of a given function in rectangular xy coordinates when attempting to describe the behavior of a polar function. So let's go ahead and utilize that tip then. Let's start by graphing this function 2 minus 4 cosine theta, where the 2 represents the midline, 4 represents the amplitude, so that would take this up to a value of 6. That would bring us down to a value of negative 2. This is cosine, but the amplitude's negative, so it gets flipped. And our function would then look something like this. Realize you might need to find the period as well. The b value in this case, though, is just a value of 1. So the period is just 2 pi. You might label some of the values on your x-axis. We know the maximum is going to occur at pi then. But the other value they're kind of showing us when I look at these answer choices is 5 pi thirds. That pops up quite a few times. Well, one thing you can do to figure out where that is on your graph is you could go ahead and plug that value in. By plugging it in, we're going to figure out its actual location. So, doing that, we plug in. We end up getting 2 minus 4 cosine of 5 pi thirds then. 5 pi thirds, you could analyze where that is on the unit circle and get a value of 1/2. So this is 4 times 1/2, which is 2. 2 minus 2 gives us 0. So that must be this spot here that we get an x-intercept at. Okay, well now we have all the coordinates that we need based off these answer choices. Well, let's go ahead and analyze each of these. The first thing I'm looking at then is the distance increasing between pi and 5 pi thirds? Again, distance means you're getting further from the x-axis, which would be shown by getting further from the origin on a polar graph. Well, pi to 5 pi thirds, we're getting closer to the x-axis. That answer is not good. Okay, we can look at that same distance there. Is the distance decreasing there? Well, yes, it is. So this answer might work. We'll keep that one in mind. Let's look at the other interval, though, from 5 pi thirds to 2 pi. Notice that distance is going away from the x-axis. That means the distance is increasing, not decreasing. So I can get rid of answer A and answer D. Well, now, which one has the correct reasoning? Let's start with answer B. Is the distance increasing? Because for that pink section, it is negative and increasing. Well, it is negative. It is below the x-axis. That is true. But is it increasing? Is the function going up? No, that is incorrect. This must be our answer. Is the green section positive? Yes, it is above the x-axis. Is it decreasing? Yes, it is going down. We have now answered example 2. Example 5 says, consider the graph of the function f of theta equals 3 minus 3 cosine theta in the polar coordinate system. What is the average rate of change over this interval? Well, 2 ways you might do it. You might graph it and try and analyze it that way. But average rate of change, we also have a formula for. We've looked at average rate of change quite a bit this entire year. So we want to find f of b. Well, our b value in this case is pi. We could plug that into our function. We could then subtract that with our function where we evaluate it at the a value of pi halves over the denominator of subtracting those two inputs. From here, this is just a lot of simplification by hand. It might take a little bit of time to do that. 3 minus 3 cosine of pi. Cosine of pi ends up giving us -1. So you can multiply those together. Cosine at pi halves is 0, so this would be 3 times 0 then. Notice I'm just taking my time as you go through this. That way you're limiting the mistakes that might arise. The bottom, simplify that. Pi minus pi halves, you would just be left with pi halves. Continuing our simplification then, the first parenthesis would come out to 6. The second parenthesis would come out to 3. 6 minus 3 then is 3 over pi halves. But let's make this not look as bad. Let's get rid of the double fraction. That 2 would end up multiplying on top when you copy dot flip and get 6 over pi. You could also divide that out as well if you wanted to get a decimal approximation. We have now found the rate of change for a polar function. Same idea as before. Here's number 6 then. The figure shows the graph of the polar function. Again, we're given a polar function. We may want to graph that then. On which of the following intervals is the average rate of change equal to 0? So we don't need to calculate the average rate of change for each of these. We just need to know which of them has a rate of change of 0. Well, average rate of change, remember, is shown by connecting two coordinates on a graph and looking at, okay, is that graph positive, right? Is it going up when you connect them? Is it going down when you connect them? If your rate of change is 0, that means you connect two dots and it's a flat line. That would be a rate of change of 0. Let's go ahead. Let's start by graphing this function and seeing what it looks like. Notice we want 0 to 2 pi. In this case, the period is pi. So I'm going to need 2 periods worth to graph this. It is sine, so I'm going to start here at the middle. There's 1 period. There is 2 periods. So here is 2 pi. Here would be pi then. So this would be pi halves. This would then be 3 pi halves. Looking at some of the answers, they're in pi fourths, so I may need to get more of these. If I take pi halves and cut it in half, that would give me this maximum where that happens at pi fourths. 1 pi fourths, 2 pi fourths, this one would be 3 pi fourths, 4 pi fourths, 5 pi fourths here, 6 pi fourths, so this is 7 pi fourths. Okay, well from there then, we want to know which of the intervals is the rate of change equal to 0? Which of them could we connect with a line and that line is flat? Well, pi fourths is up here, 3 pi fourths is down here. That rate of change looks negative. That does not work. Answer B, 3 pi fourths to 5 pi fourths, here to here then. That rate of change is going up. I missed this dot a little bit, but you get the point. Okay, that is then positive rate of change. That one is now gone. I look at answer C, 3 pi fourths to 7 pi fourths. Notice when I connect those two dots, it is a flat line there. That is exactly what we want. That would be a rate of change or an average rate of change of 0. Pi fourths, 7 pi fourths, that one looks negative. That one would not work. Let's look at one more example. Using that same idea, we now want to figure out which of these rates of change is the least. You don't have a function here, so you can't graph it. But remember, what we were looking at is the distance from the x-axis is what we were analyzing. Well, if I want to look at distance from the x-axis here to see whether it is 0 or not, or whether they're the same or not, from A to B, notice the distance between those. The distance from A to the origin and B to the origin is the same. One's just a positive and one's a negative there. So the rate of change is not necessarily changing. It is 0. Your distance is the same. From B to C, well, B is closer to the origin than C is. So from B to C, you're going further from the origin. That means your rate of change is increasing, meaning your rate of change would be positive there. Your distance is increasing, so the rate of change is positive. From C to D, they're the same distance from the origin. And from D to A then, notice you're getting closer to the origin. Your rate of change then must be negative because the distance is decreasing. Then we can have negative here. So which of these gives the average rate of change that is the least? That would have to be the one that is negative. If you want to see just some clarifications on where I got each of those, here you go. I did say it verbally, but just to clarify, we said the rate of change was negative. That was because R decreased. We knew this was positive because R increased. And then we knew these were both 0 because R stayed the same. And there we go. That is it for this video. That was the first of our 2 videos for 3.16. Thanks for watching. Come back next time for more on polar graphs.